Welcome to today's lecture. Today's topic is on the consistency and independence of the system of linear equations. What we are basically going to study in this lecture is that we'll try to determine whether the system of linear equations are consistent or inconsistent, and we'll also verify or cross-check whether the system of linear equations are independent or dependent in the later part of today's lecture. The objective of today's lecture is to learn the consistency and inconsistency of the system of linear equations, and second part of this lecture will focus on understanding the independence and dependence of the system of linear equations. First, we'll go through the definitions of consistent and inconsistent system. So what is meant by consistent system? A system of linear equation is said to be consistent if it has at least one solution. That means any system of linear equation with at least one solution is said to be a consistent system. Next, what is meant by inconsistent system? A system of linear equation is said to be inconsistent if it does not have even one solution. That means any system of linear equation that does not have a single solution is said to be inconsistent. So next, how do you check or determine whether the system of linear equations are consistent or inconsistent? To do that, we have some criteria to verify whether the system of linear equations are consistent or inconsistent. The test or the verification of the system of linear equation for consistency or inconsistency is basically what you have to do is that in the first step you have to determine the determinant of the coefficient matrix A. If the determinant of the coefficient matrix A is not equals to 0, then we say that the system of linear equation is consistent. And in case if the determinant of the coefficient matrix A is equals to 0, then you have to further test these two conditions. So if the determinant of the matrix A or coefficient matrix A is equals to 0, if you first check the next condition, the product of the adjoint matrix A and B is equals to 0, then we say the system of linear equation is consistent with many solutions. However, if the product of the adjoint matrix A and B is not equals to 0, then we say the system of linear equation is inconsistent. Next, we'll go through the example. So let's take this example. Is the system of linear equations consistent or inconsistent? So we are given with this two linear equations, the system of linear equation. In the first equation, we have 2x minus 3y equals to 3. And the second equation, we have 4x minus 2y equals to 10. So to check or verify whether the system of linear equation is consistent or inconsistent, the first step is to get the coefficient matrix A. So our coefficient matrix A is 2 minus 3, 4 minus 2. So as you know, the matrix A is the coefficient of the linear equations. So now if you go to the conditions for testing whether the system is consistent or inconsistent, so now you have to find the determinant of this coefficient matrix A. So our determinant of coefficient matrix A is equals to minus 4 minus minus 12, which is equals to minus 4 plus 12, which gives answer 8. So now we have computed the determinant of our coefficient matrix A, which is equals to 0. So based on our conditions for the test of consistency and inconsistency, we have to check whether this determinant of coefficient matrix is equals to 0 or not equals to 0. In this case, our determinant of this coefficient matrix A is not equals to 0. Therefore, we can say that this given system of linear equation is consistent and has a unique solution. So now let us go through the dependent and independent system of linear equations. So basically, how do you determine whether the system of linear equation is independent or dependent? So first, the definition. So what is meant by independent system of linear equations? A system of linear equation is said to be independent if its determinant is non-zero. Basically, we call a system of linear equation as independent if the determinant of the coefficient matrix A is not equals to 0. And next, so what is meant by dependent system? A system of linear equation is said to be dependent if its determinant is equals to 0. That means whenever we have the determinant of our coefficient matrix A equals to 0, we say the system is dependent. So now let us go through an example to determine whether the system of linear equation is independent or dependent. So in this example question, we are asked to verify whether this system of linear equation is independent or dependent. So our first equation is 2x plus 4y equals to 3, and our second equation is 4x plus 8y equals 7. So first step in determining whether the system of linear equation is independent or dependent is that first you have to get the coefficient matrix A, which is 2, 4, 4, 8. So next step is to check the determinant of this coefficient matrix A. So let us find out the determinant of this coefficient matrix A, which is 8 to 16 minus 16, which is equals to 0. So according to the definition of the independent and dependent system of linear equations, we said that whenever the determinant of the coefficient matrix A is equals to 0, the system is dependent. So therefore we can say that this system of linear equations is dependent.